Hello, my name is Mikhail. I'd like to talk about this issue that I fixed recently. So we're seeing timeouts in the tunnel functionality where kubectl couldn't get a reply from the server from CAS in 32 seconds or at all. So before bumping the deployment to a new version, Graham, thank you, Graham, took the coroutine stack trace dump using pprof, and that helped us a lot to understand what's wrong. So you can see the stack traces here, and then I opened the merge request, fixing the deadlock. So yeah, it turned out it was a deadlock. And so I want to talk about how I found the problem and how to read stack traces and how the TunnelRegistry works in general to start with. So first of all, let's open the code. And when you are looking at stack traces, the first thing you always need to do is to open the correct version of the code. Otherwise, line numbers don't align quite often. So especially for a fast moving project or when you update dependencies. So this was RC1, 14.5 RC1. So let's check out that version. Vision. This version, RC2 is the version with the fix. This is the version that was buggy. So basically, let's first talk about how the TunnelRegistry works. It lives here in the reverse tunnel module in the root because it could be used by something else, not necessarily the server or the agent. It is currently only used by the server, but yeah, if we decide to do something else someday, it might be used for something else, or by some other code. Who knows? So how does it work? TunnelRegistry implements two interfaces: tunnel finder, find tunnel. This is the method that is called by the CAS that needs to find a tunnel to an agent. And the second interface is tunnel handler, which is also called by the CAS, but the one that accepted the connection from an agent. So first we register the connection, basically, incoming connection from an agent, and then some other connection from another CAS. We'll try to find the correct tunnel to forward the request to. So these are the two interfaces that TunnelRegistry implements. And the way it works is basically, if you've heard of actor model or actors, then you should understand what it means, how it works. The idea is that you have an independent, well, what's called an actor that owns some state, and then it processes incoming messages and sends outgoing messages. So an alternative approach is to have a piece of shared state, and then whoever needs to do something with it, read or write, grabs a lock, performs the mutations or whatever it needs to do, read, write, both, then releases the lock, and then some other thread may come along and do something else. And yeah, so with actors, the actor owns the state, and then it's a Go routine that just runs and listens for incoming messages and when it gets a message over a channel, it does something depending on the message usually, and then it may send out messages, or depends on what it wants to do. So the difference is there are no locks. There is a dedicated Go routine, and it interacts with the outside world with other Go routines via channels. I like this pattern a lot because it allows you to use contexts. They just compose nicer with the blocking calls over channels. You can mix in periodic things that need to happen within that Go routine. Like you can have a timer that fires every n second to do some garbage collection or some background activity, even if there are no callers. If you do this via logs, then you need to have a separate, thread or Go routine that wakes up every n seconds, grabs a log and does whatever it needs to do. Yeah, and with actor, you just have a loop. This runs in a separate Go routine. It, as you can see, it reads from channels. These are all channels. You can see that here. We have 4 channels. We select on all 4 channels, and also we have the context where we are told by the thing that started us that we can stop. We need to stop. If we needed to do some garbage collection, we would have a ticker here that would tick every n seconds, let's say, and then we would have an extra case, and we would receive from that ticker channel, do the periodic task, and then continue. It's a pattern that is very nice, I think. So what are the channels we do? So we have, as I shown you here, we have 2 interfaces that we implement, and basically we have requests to register. This is the first one, and then requests to unregister when the context is cancelled, and then we have requests to find a tunnel and requests to stop looking for a tunnel when context is done. So let's look at the handle tunnel. So yeah, that's where we receive register, unregister, find, and stop finding, abort find request. So let's look at the handle tunnel method. So this is called by, you can see it's called here. This is the connect method of the reverse tunnel server, and it's called by an agent which wants to establish a reverse tunnel connection. Does authentication here and then delegates to handle tunnel, and polling stops when this returns. And this is a blocking method, so it will. We can see what it does. So that's not important right now for this conversation. I just want to go over it. Go over the high-level logic without the details. So we register the tunnel, then we either wait for the cancel or for an error to return, so to unblock the incoming connection, return whatever needs to be returned to the incoming connection. And then if the context was canceled, here we haven't registered, so we just return. And here we have registered, so we need to unregister. So that is what we do. We try to tell the run Go routine that we want to unregister. Alternatively, if someone has picked up the tunnel already and is trying to send us a reply, like what to return, we are reading from this return error channel. And here, if we have unregistered, the contract is, we still need to return something, right? So we read from this channel as well. So this is the part that is called by the server method that is called by an agent, and this is it. It's a blocking call that sits there and registers, waits for a reply, or if the context is cancelled, unregisters and also waits for a reply. That is straightforward, but look how nicely it works with contexts. Imagine using a mutex here, and you would need to have another Go routine that waits for a context cancel. Then you would need to use broadcasts on mutexes to tell the whoever holds the, yeah, I don't even know how it will work. I don't know. I mean, of course, everything is possible, but it's just better with channels in this particular case. So let's look at the other method, which is called by, it's also, this is the router that routes the request from one CAS to the request that's coming from a CAS to gateway. So routing CAS, gateway CAS, agent, that's the chain. So this code is being executed in the gateway CAS, the one which has the agent's connection that was received by the connect method. And so here we are finding the tunnel, and we are using the context to stop looking for the tunnel where when or the context is cancelled. Then once we have found the tunnel, we are using the tunnel here, forwarding the incoming stream. There is plumbing here. Let's not talk about this now. And once we are done, we are calling done on the tunnel to. So if we have sent something there, performed send or reads on the stream, then done will just change the state. There's a simple state machine inside. If we haven't done, then it will just return nil to the return channel, so that this method is unblocked and we return something here. Otherwise, it will get stuck forever. So you see, it's a deferred function. So even if we have an error here, let's say, we will still unblock the connect method. Then let's look at the find tunnel implementation. Also, let's not talk about this. Well, we create the requests to find the tunnel, find tunnel requests, and then we send that request to the find request channel. So we are sending to that actor Go routine. That I think of it as this. We have an actor Go routine. It's like spinning in that for loop. Then we have incoming requests to connect. Oh, it's difficult. Connect. Connect. Yeah, and then we also have requests to find. To find the tunnels, and state is here maintained by that Go routine, and these requests are sent to us by, maybe without the loop, but by other Go routines. Let's just one and two. So it's like actors or Go routines talking to each other via channels. So here we are sending sending the find request to this one, and then here is a two case select, case one, case two. We are either waiting for the contacts to be canceled, this one, or for tunnel to be returned from that main actor coroutine. And if we got that tunnel from it, from the main coroutine, we return it. If we got new, because that's possible when this thing is shutting down, we just return cancel. Here, if the context was canceled, we need to tell that this Go routine that find request is, we are no longer interested in the result. And if there is a result actually concurrently with this, then we get and we got the tunnel that is not new, then we just close it or done it immediately. Okay. So these two methods are very similar. Also, contexts and channels compose very nicely. So let's look at the run method, what it does. Well, I have shown you. So this is the register, it handles the registration, then unregister, it handles unregistration, and find the board. So this state is maintained in these maps. We have tunnels, then tunnels by agent IDs. This is just like a secondary index in the database to make it easier to find tunnels by an agent ID. And then we also store find tunnels request by agent ID. So I will not go into details how this works, but you can imagine how there's nothing super interesting. So let's look at, so we have checked out the correct revision. Let's look at the, this is the merge request that fixes the problem. Here I copied the stack traces of the relevant Go routines. So this is the first one that we have 815 Go routines blocked trying to register. So they are calling handle tunnel. So this is all the Go routines that from agents that are trying to establish a new tunnel connection. And we can see this here by the stack trace, the connect method, or we can just copy this and then 2 times shift, paste, and just you can go here immediately. Your favorite editor can probably do this as well, or you can just navigate to the path and line, and you see they're all calling handle tunnel. And let's look at inside of handle tunnel where it actually is blocked. So it's blocked on this select, and that means it's trying to register this tunnel. So, and here we do not see, because it's an aggregated view, pprof tells us that there are 815 Go routines blocked here. If you look at so non-aggregated view, which it can also give you if you pass there's a query your query parameter. 1 aggregates, 2 doesn't aggregate. If you look at individual Go routines, it will show you for how long this particular one has been blocked. So this one doesn't, because there are 800. There is no, like, you can tell for how long all of them have been blocked, because it's each of them has a separate lifetime blocking profile. So anyway, they're all blocked trying to register the tunnel, and that's not normal. It should be instantaneous, because the actor Go routine doesn't do anything else. It just reads from tunnels, from channels, does in-memory modifications of the state it owns, and then it also replies via the other channels. that are passed, like find request passes a channel, for example, and also the register request passes a channel to reply to for this particular request. So it should be instantaneous. This goroutine doesn't perform any IO, doesn't perform anything that can block for a long time. Because if it blocks, it's a deadlock basically. So then we also have 773 goroutines that are calling the handle tunnel. So these are 700 something goroutines that they were trying to perform a Kubernetes API call, and they got stuck. And that's also not how it should work, obviously. We can also just navigate to the line, and they are blocked. In this case, actually, they have registered the interest in. Did I copy that? Yes. So they're trying to unregister. Okay, these ones, yeah, they have registered, but then they were trying to unregister a tunnel. Oh, okay, this is still the handle tunnel, not find. So yeah, these are the ones that are trying to unregister because the contacts have been cancelled, and they're stuck here. There's no reply to return, and it also couldn't unregister anything. And then there should be another one, which is the find, yeah, forward stream on the tunnel. So this is the one where wait, it's not doing the right thing. It's not opening the right file. Okay, now it does. Okay, here, this is the right. Yeah, be careful when you are navigating this. It sometimes doesn't go to the right place. So this is the forward stream, which is called by the incoming request, and they are all blocked trying to read from my goroutine performing the proxy, but it's stuck. Okay, yeah, this is a different problem, was fixed in a different goroutine, and this is the problematic stack trace. It's only one because that's the actor holding the state, so it's always only one. Otherwise, we would need matrices, and it's handling some unregistration of some tunnel. And what it's trying to do, it's trying to return a new to put a new into a channel that is then used by the handle tunnel. Yeah, this is the one that. Yeah, this is the channel it's trying to write to. It's unbuffered, so someone must be reading from it for the write to succeed. But yeah, the only case where there is no one reading is if someone has already read from this channel, or if we shouldn't be writing to it. And the problem here was that yep. So the problem here was that logic in this line was wrong. It's just it should be checking. Well, look at the merge request there. But or we can just get the master. Yeah, it should be checking if this particular tunnel is still registered with that actor goroutine, or if it has been removed. If it hasn't been removed, if it's still registered, then we call done to unblock it, and then we remove it from our state, in member state. And yeah, wrong if condition led to a deadlock. Yeah, so I think that's pretty much it. Let me know if you have questions. Thank you.